Okay. Yeah. So here we discuss communication from like a source to destination, like sending, right? Sending. So while you are sending, what happened? Application to physical layer. But when you are sending and receiving, both sides will see. Okay. For example, I have a PCA, one system. Another side is B system, PCB system. So you are sending a data here. Sending data. Okay. The first layer is application layer. What application you are using to send the data? Next, what protocol you use to send the data? Okay. So simple for our understanding. Next, whatever the data it is, it's going to be encoded. What data it is, what are the format of that data is, it should be encoded. Next, and it is compressed, encrypted in a presentation layer. And next, session layer. So a new session is created for this communication from here to here. So for what type of communication and based on the source and destination. So for this section, for this communication, a session ID is created. And what are the data you are sending that is added? This session ID is attached. And this session is maintained till the completion transaction between source to destination, destination to source kind of stuff. Means A to B, B to A, complete transaction completed. Okay. So that is till that time the session is maintained. Okay. And of course, you are sending, receiving, there is a authentication information. Your username, password, their username, password, that information is added. Next one is transport layer. So main transport layer, what are the data up to here? It's a complete set of data. Maybe it is encoded or encrypted or compressed, but it is complete set of data. This data is chopped into small pieces called segmenting. The process called segmenting to that segmented data. So you have a multiple segmented data are there here, multiple segmented data. Each segmented data is attached with what is the protocol you are using, that port number. So that the protocol also either TCP type or UDP type wise it is added. What is your segment number? So number of segments you are sending, that information is also added. Okay. So that information is also added to your every segment, to each and every segment. So to this segment, at a network layer, what happened? Source IP. So what is your source IP? A's IP address and B's IP address means destination IP address added to your segment. Okay. And now this is what we call it as packet. Segment packet. To your this packet, now it is a data link layer. MAC address, source MAC address means A's MAC address and B's MAC address is added to your packet. Now what we are calling it as frame. This frame is converted into bitstream. And based on your physical connectivity, it can be converted into electrical signal, or it can be radio waves, or it can be light waves. So this is what we have discussed just before in OSI model. So how much time it is taken? Very less, right? Very. Now you're sending a data. The data is sent through your switches, routers, and finally it reaches. So what are the media it can be? This can be if you are connecting through Wi-Fi router or wireless access point. So it is different type of signal. You are sending through switches, hubs, then it is electrical signal. But what are the signal mode you reach finally at destination? So this signal is again convert in physical layer. Again, it is converted into bit stream. So you reach to the physical layer only, physical adapter only, right? So bit stream. And this bit stream again combined and it is created a frame. This frame is sent to the data link layer. So this data link layer opens this frame and see the source MAC address, means that sending MAC address and destination MAC address, and packet and CRC value. So there's CRC value also there, I forget to mention here. So it uses CRC value to make sure that its data is good or corrupted. It uses the CRC value and check the data is good or corrupted. So error detection is happening here. And it take the incoming packet source MAC address. Incoming packets source MAC address kept a place. Okay. So it is a SmacA address. It kept in the table called ARP table. ARP table. It kept the incoming packet MAC address here. And verify the destination incoming packet destination MAC address with our MAC address, system MAC address, adapter MAC address, right? So both are same, then it accept the packet. Then it is accept the packet. So finally, we have received a packet here, right? This packet is sent to this network layer. At network layer, it opens and see the source incoming packet, source IP address and destination IP address. And there is a segment. Okay. There is a segment information. So it verifies, it takes this incoming packet source IP address, put it in our ARP table like this. This is incoming packet source MAC address, incoming packet source IP address. Both are mapped in this MAC address, sorry, ARP address table. Address resolution protocol table it is. And it verifies this incoming packet destination MAC address. Is both are same, both device means the destination device where it is received, that device and this IP both are same, the device IP address and this both are same, yes, accept the packet. Because sometimes you see the hub switches also, they send a packet to other devices. So other devices like D device is received, E device is received. There should be verified it is my packet or not. How it will verify? But in based on incoming packet destination addresses, right? This is MAC address and IP address it will verify. And it is good, IP address is correct as per me, then it is as per that device it is accepted. Otherwise, drop the packet. Okay. So finally, there is a segment. So it is accept the packet at this level. So at a transport layer, so we received these segments, right? These segments will be arranged. So we are keep on receiving packets now. Okay. Each packet is processed from here to here. And finally, we received all the segments. All the segments here. And these all segments will combine and make it as a single data part. Okay. These segments will be combined at a transport layer. That's it is called end-to-end connectivity. These segments are assembled at transport layer. So where it is stopped, transport layer. Where it is assembled at a destination, transport layer. And so along with this segment, so there is also protocol information is also there, right? Port numbers also there. TCP, UDP protocols and their port numbers also we are getting. So finally, you got a data and what protocol. So then system, what it will do, it check this protocol port number data, TCP, UDP port number data it is checking. So based on that protocol port number, it connects that what application is responding, what application should give respond to this particular request or information. For example, A is a web client and B is a web server. You send a web related request. Said B, web services should be responded. Or A is a mail client and B is a mail server. You send a mail access related request. So where it has to be connected B side is mail server application has to. So based on these protocols and the port numbers, the system understand which application is responsible for this request. So it will connect to that application. Okay. So again, this session ID is verified. Authentication and authorization information is verified. It saves this session till the transaction completed. Next. Okay. So this because the entire transaction has to be completed in same session. Next, presentation layer. So at presentation, your data is encrypted, decrypted. Data is compressed, decompressed. Data is encoded, it will be decoded. So finally, you got a data, right? Next is finally application. So based on these protocols, port numbers, what application it is should be respond. That application has to be understand what is this request you are sending, what information you are sending, what request you are sending. It will understand and it will try to give a reply to you, a response or a reply to you. So again, it is ordered like this. But how it is? Application layer, again, what reply protocol and what is the reply data, what application should be respond, that is application. And presentation layer, again, encoded, encrypted, okay, encoded, compressed, encrypted data. Then it is session layer. It is maintain that session. No need of creating new session. It's in the same session only. But it will add that authentication, authorization information. Data, session ID is added. Okay. And a transport layer data is again segmented. Okay. Protocols, what protocols when we are communicating, the TCP, UDP protocol port numbers are added. That is, we are sending to network layer, network IP. Okay. Source IP address, destination IP address added to your IP addresses for your data, segmented data. Then it is DataLink layer. Source means B's MAC address and destination means A's MAC address is added. Okay, and some data is added, and it is the frame send it to the physical layer. It convert into bitstream based on the physical connectivity. It convert into that signal format. And finally, it receives at a destination physical layer. Again, it converts this signal into the bitstream to frame. In a frame, it verifies. The first is CRC, verify the data error detection until then, and check the source MAC address, incoming packet source MAC address, destination MAC address. Destination MAC address is same or not. Of course, incoming packets, right? Again, in this destination side, ARP table is also there. In this ARP table, so B's MAC address and B's IP address added. Network layer, source IP, destination IP is there. So you take the source IP, incoming packet source IP, put it in a MAC address ARP table, verify the destination IP with a ACE IP address. If it is correct, same, then it accepts the packet. Data, the chopped data, the packets are received. Finally, it is assembly transport layer. Session ID verifies is same session or different session. And protocols also verified here. Protocol port numbers are verified and connected to that what kind of application related it is. It will go to that application, it forward to that application. Session ID verifies, again authentication authorization, session ID is also verified. Presentation layer, again reverse order. That is, data is encrypted, decrypted, compressed, decompressed. Okay, next is encoded. It is decoded here. And finally, application, the present data is presented your application side, or maybe give some output on your application side. So it is always while we are sending application to presentation, while receiving while you are sending application to physical layer, while receiving physical layer to application layer. Okay, so this is what it is happen when you are communicating in the network. Voice model voice. So this is the part. You may get a doubt, so sir, why I'm telling this ERP table? Guys, when you are sending a data, okay, listen carefully. When you are sending a data, you are using source IP address. Okay, your system having source IP means A IP address, and destination IP is B's IP address, right? You are mentioning B's IP address when you are communicating. And your system knows source MAC address, okay, which is A's MAC address. But what is the destination MAC address? You didn't mention, system also don't know, for at least for the first time you are communicating. First time you are communicating, you don't know the destination MAC address. So it's not a B's MAC address. So what to do in this place? So they use a MAC broadcast address for first time you are communicating. So they use so for destination MAC address, what system use? System use a MAC broadcast address, which contains 12 Fs. This is the MAC broadcast address. Instead of B's MAC address, it use MAC broadcast address, but it will send successful. So packet is received at destination side, means B side it is received. So it is verify it got this A's MAC address, and a B's MAC address is not there. Instead of B's MAC address, actually what is there is MAC broadcast address is there. So that's why it is verified. If not, it is B's MAC address. It's good. Not it's MAC broadcast. It's okay. In general communication, in security basis communication, it is very important. Next, anyway, we are confirm our communication with the B's IP address, right? B's IP, our system IP both are same. Then only we are accepting packet anyway. Okay, and also you are getting A's IP address in the packet. So we put a A's IP address and B's MAC address in the ARP table in this B system, in the B system. Okay. So we are replying, and replying again from B, source IP is B's IP address. Source destination IP, anyway it is A's IP address. Source MAC address is B's MAC address, because B is sending, B knows its MAC address. And destination MAC address. What is the destination MAC address? Are we adding this broadcast ID? Not required. Why? Because earlier we learned this information from the incoming packet. From incoming packet, we check the source MAC address, source IP address. We put it in ARP table, address resolution table. So from that one, because this is destination is A's IP address. So then it is A's MAC address automatically. That is the use of this ARP table. So no need to use MAC broadcast now. To send a packet and B is received a packet, A is received a packet. Okay. Again, A is sending packet. Now A is sending packet. So see, it is A is sending a packet. So before that one, A is also received a packet, right? Here it is. So A received a packet from the B. So it check the incoming packet source MAC address. This MAC address by incoming packet this MAC address and incoming packet which is source, right? Incoming packet source MAC address and source IP address. The MAC address, the IP address is got it and put it in ARP table when B is send a packet to this one. So next time it is sending, what it will do, it use this information. So source MAC address, destination MAC address, source IP, okay, destination IP. Okay, so like that. So initially, system may not be known the destination MAC address, but when communication is happened, whenever any incoming packet is came, so it will check the incoming packet, source MAC address, destination MAC address, source IP address, destination IP address, incoming packet. It take that IP address and MAC address, put it in a table called ARP table. It's a temporary only, guys. If you shut down your PC, this information is gone from your system. Okay. But it is help your system next time it is use exact IP addresses in security places where the security is more important. So compulsory statically people entering this data. Static entries are as a permanent data, but dynamically learning like this is temporary. Okay, understand guys? Sending and receiving. New message. Yes, very good. Okay, so there is a TCP IP and OSI model comparison and troubleshooting using OSI model. Okay, we'll take care of this thing tomorrow. Okay, of course, this is also one point. So we'll see from here, we're going to discuss tomorrow, guys. We'll try to complete this networking topic tomorrow, including some troubleshooting. Okay. So that's it for today. Please be prepared for what are the tests you are going for. Okay. Please be prepared. So that's it. That's it for today. I think it is, Bye bye.